The volume merge process vertically combines two volumes at a specified boundary. The output volume consists of the top volume above the horizon and the bottom volume below the horizon. Volume merge can be used to splice together velocity volumes created by different processes. In this example, I have two velocity volumes. The first volume is made from well check shots, but the time depth curves all start deep in the section, creating a constant and blocky shallow section. The second volume is a velocity V0K model and shows smooth lateral and vertical velocity changes in the upper layer. I will combine these volumes to get the best features of both models. To ensure I maintain the well tie, I will merge the data using average instead of interval velocity. Using the volume conversion process, select the input checkshot interval velocity and change the output to average velocity. Display the checkshot average velocity to check the results. Select a new volume conversion process. Select the input V0K interval velocity volume. Change the output to average velocity. Display the V0K average velocity volume to check the results. So far, so good. Both these volumes look as expected. Select the volume merge process. Select the average V0K velocity in the top volume. Select the average checkshot velocity in the bottom volume. Select the boundary. This could be a constant, but in this case is a horizon. The velocity has been carefully conditioned to ensure consistency at the boundary, and so a ramp is not required in this case. Both volumes must be aligned for this process to work. This means the same survey type, 2D or 3D, and the same sample interval in X, Y, and Z. Insight makes these edits easy, but as always, check the results for accuracy and consistency. The average velocity does not show much visible difference, and so convert the average merged volume back to interval velocity. The model looks good as interval velocity, and by merging using average velocities, the wells still tie. Good job! Some models cannot be reasonably merged without introducing a depth shift or extreme interval velocities. Here is an example where the shallow layer is now derived from a synthetic linear velocity model that initially looks quite reasonable. After converting to average velocity and merging, the model still looks fine, until we convert back to interval velocity. In order to create continuity between the upper and lower volumes, a high velocity value has been introduced at the boundary event. Insight recognizes this is unusual and immediately throws a warning. Visually, the bright event can be seen in the section view along the merged boundary. A quick fix for this would be to gradually blend the velocity over a window using the ramp function. The process applies a linear ramp from half the ramp distance above the merge point to half the distance below. For such a high value, the window needs to be quite large, but it can be offset so that it only affects one of the layers instead of both. Carefully conditioned input data will always give the best results, but even with mismatching input data such as this, Insight provides the tools to quickly identify and correct issues. If you have questions or would like to discover more, then visit our website at www.doug.com. And remember, have fun with Insight!